My warm regards to everyone. I am Pragati Pal, pursuing B.Tech from Lucknow University in Civil Engineering branch. This is my seminar presentation on water treatment solutions, and the presentation has been made under the guidance of Engineer Jitendra Pratap Singh. My presentation will consist of the following things: introduction, water treatment, what is the water treatment, its need, the solutions, water treatment plants for the removal of iron arsenic fluoride, water ATMs, the technologies involved in wastewater treatment, moving bed bioreactor, membrane bioreactor, activated sludge process, the case study, and the references from where I have taken help to make this entire presentation. Out of the five elements we know, water is one of them, which signifies its importance in our lives. Water is one of the most important basic element on which the planet Earth is based. What we mean by the treatment of water is any process that improves the quality of water to make it appropriate for a specific end use, that may be drinking, industrial water supply, irrigation, river flow maintenance, water recreation, or anything. Water is a precious resource which we all need to survive and is one of the important factors in determining the life and health of society. Water treatment may involve different types of operations. These operations can be physical, physiochemical, chemical, and biological. Now, why do we need to treat water? The aim is to eliminate or to reduce the contamination or non desirable characteristics of water. Since we know that there is so much of pollution around us, there are n number of factors which lead to the contamination of water. The objective of the process is to obtain water with the right features for the use intended to it. Water treatment is increasingly necessary due to drinking water shortages and the growing needs of global population. Only 2.5% of fresh water is available from the water reserves, and out of this, only 0.4% is the water fit for human consumption. Water treatment not only removes the harmful contaminants but also improves the taste, smell, and visual appearance of our drinking water. It reduces the amount of chlorine, soil residues, organic and inorganic matter present in water. Following are the advantages of water treatment plant. It removes the impurities and other contaminants from water. It protects the environment by not releasing harmful chemicals into the atmosphere. It produces clean water, which is safe to drink. It reduces the risk of waterborne diseases. The treatment plants are very necessary for our society. A clean and germ free environment will boost our productivity and help us stay healthy. As the population of cities and other municipal areas continue to grow, maintaining sustained access to sufficient amounts of clean potable water progressively becomes more important. Through the practices of environmental and water resource engineering, civil engineers are constantly advancing the development of such systems that deliver clean water effectively and reliably. It is tried to make water accessible to everybody. On the screen, we are seeing the different water treatment solutions which are present: water softener plants, water ATMs, ultrafiltration techniques, iron arsenic removal plants, fluoride removal plants, activated carbon filtration, etc. The first and foremost is iron removal from water. The presence of excessive iron can cause discoloration of water, laundry, and plumbing fixtures. If we talk about the source, the iron present in water comes from the large amount of iron present in soil. The working principle of removing iron content from the water is the oxidization of iron. In this process, the iron's ferrous or dissolved state is converted to a ferric or undissolved form. After that, when the conversion takes place, the ferric form of iron precipitates on the filter bed. The next is fluoride removal from water. Fluoride is known to occur at elevated concentrations in a number of parts of the world, and it has significant adverse impact on public health and well-being. India is one of the worst fluorosis affected countries with a large number of people suffering from it. This is because a large number of Indians rely on groundwater for drinking purposes, In India, 62 million people, including 6 million children, are estimated to have serious health problems, be it dental and skeletal fluorosis, due to consumption of fluoride contaminated water. As per the Indian standard 10500 for drinking water, the permissible concentration of fluoride in drinking water is 1 mg per liter. Essentially, reverse osmosis technology is used for the removal of fluoride. The water passes through a semi permeable membrane as well as additional filters such as sediment or carbon filters are used. The next is arsenic removal from water. Arsenic is naturally present at high levels in the groundwater of several countries. Arsenic is highly toxic in its organic form. Contaminated water used for drinking, food preparation, and irrigation of food crops poses the greatest threat to public health from arsenic. Long term exposure to arsenic from drinking water and food can cause cancer and skin lesions. It has also been associated with cardiovascular diseases and diabetes. In utero and early childhood exposure has been linked to negative impacts on cognitive development and increased deaths in young adults. The most important action in affected communities is the prevention of further exposure to arsenic by provision of safe water supply for drinking and food preparation. What we can do is substitute high arsenic sources such as groundwater with low arsenic, microbiologically safe sources such as rainwater and treated surface water. Low arsenic water can be used for drinking, cooking, and irrigation purposes, whereas high arsenic water can be used for other purposes such as washing clothes, bathing, etc. Discriminate between high arsenic and low arsenic sources. For example, test water for arsenic levels and paint tube wells or hand pumps with different colors. So, this can be an effective and low cost means to rapidly reduce the exposure to arsenic when accompanied by effective education. We can also blend the low arsenic water with high arsenic water to achieve an acceptable arsenic concentration level. The technologies for arsenic removal include oxidation, coagulation, precipitation, absorption, ion exchange, and membrane techniques. The next is water ATMs. So, water ATMs were introduced to make water accessible to everyone. A water ATM is an automated water vending machine that dispenses pure drinking water. It can be installed in urban and rural localities which do not have access to clean and pure drinking water. Some of the names are given below: community based model, school models, which will provide water for students, mobile water ATM, which can provide water anytime, anywhere, and commercial. Water ATM gives little contribution towards plastic free India, supporting the mission of Swachh Bharat as it helps in reducing the use of plastic bottles, which amount to major plastic waste generation in India. It works towards eliminating its two main causes: availability of drinking water and affordability of drinking water. And water ATMs cater to this immediate concern of common people. The various features of water ATMs: they are automated water dispensing units, they are available 24 into 7, they can be solar powered and cloud connected. Remote tracking of the water quality is also possible in water ATMs. Now we come to the water technologies which are used for wastewater treatment. The first one is moving bed bioreactor. So, this is a submerged attached growth process. It consists of a aeration tank similar to activity sludge tank with special plastic carrier that provides a surface where a biofilm can grow. This process consists of adding small cylindrical shaped polyethylene element which has specific density of 0.96 gram per cubic centimeter to support the biofilm growth. So, what are the advantages of using this technology? This is compact and simple to operate. It is very efficient for removal of biochemical oxygen demand, ammonia, and nitrogen from both the municipal and industrial sectors' wastewater. With the MBBR, operator can maximize the treatment capacity by minimizing the footprint. It can be built without RAS flow or backwashing. Additionally, MBBR increases factors such as treatment efficiency, and MBBR offers better treatment efficiency than other types of wastewater treatment systems at lower space and budget requirements. Hydraulic capacity: this can handle more water at a given time than the other system, enhancing the overall efficiency. Volumetric efficiency: with bacteria managing much of the treatment process, the parts in an MBBR system can stay in better condition. As a result, the system optimizes the amount of water flowing through the pumps. Processes lifespan. The biofilm media carriers that hold an MBR system's bacteria have a long life expectancy. In turn, the system's process lifespan also increases. The next technology used is membrane bioreactor. A membrane bioreactor is a process which combines a microfiltration or ultrafiltration membrane unit with a suspended growth bioreactor and is now widely used in both the municipal and industrial wastewater treatment plants. The crucial function of membranes is to separate the solids from a liquid. In activated sludge facilities, this is traditionally accomplished using secondary clarifiers. The two process configurations are possible: submerged MBR and side stream MBR. The next technology is activated sludge process. It has three main components: an aeration tank that serves as a bioreactor, a settling tank for separating the solids and treated wastewater, and a return activated sludge equipment that transfers settled AS from the clarifier to the aeration tank's influent. The activated sludge treatment process has significant advantages over the other alternatives. The quantity of unwanted sludge is reduced, beneficial bacteria reseed themselves in sewage treatment plants. The activated sludge treatment process allows for longer emptying intervals. The procedure is less complicated, the costs are reduced, and the method can be odorless. This process also has some drawbacks and may not be suitable for all applications. Some facilities may be discouraged due to the initial high capital and operating cost. The activated sludge system must be designed and built by professionals. Skilled personnel are required to operate and maintain the treatment of activated sludge. Higher energy consumption because electricity must be used continuously. Parts and materials may not be available locally. Sludge and effluent may necessitate additional treatment or discharge. The excess sludge eventually accumulates in the aeration tank beyond the desired MLSS concentration. So these were some of the technologies used for water treatment solution. Now here we have a case study of MBR technology. The Commonwealth Games Village near Akshardham Temple, Delhi was the third project that UEM had executed for Delhi Jal Board within a decade. So UEM built India's largest 1 million gallons per day capacity sewage treatment plant for the Commonwealth Games Village based on the company's membrane bioreactor technology. The technology is excellent for catering to requirement of consistent quality effluent with low BOD and total suspended solids for reuse and discharge. The advantages of using MBR tanks include lower fouling, reduced cleaning cycles, and gravity operation capability. And this procedure is very simple to operate. The next case study tells us that how Unicare Technologies has installed more than 250 units of iron removal plant with the help of Public Health Engineering Department in Bihar. This was done in regards to the higher iron content in water which is harmful to the human body. To solve the problem, community-based IRP are also manufactured which removes the iron precipitate through biological filters. This helps nearly 4.5 million people in the residing areas. The iron removal plant positively generates 40 million plus liters of purified water on a daily basis. And at last, I would like to add the following references which helped me to prepare this presentation so that I could know the various technologies which are used in our country for water treatment solutions and how we can get better quality of water. Thank you.